Express the recurring decimal 0.456 and with the 56 recurring as a simplified rational number. The difficulty here, of course, is that the 4 doesn't recur. This number is 0.456, 56, 56, 56, and so on. There's a couple of different ways you can go around this. I'm going to let x be equal to this. And then if I do 10x, that gives me 4.56, 56, 56, and so on. Now, to produce another number that has the same decimal, if I multiply by 100 so that my decimal point is in here, that's going to be 1000x is 456.56, 56, 56, and so on. If I subtract, because the decimal's the same, I'm just going to end up with a whole number. The decimals are going to cancel out. So if I do this one, take away this one, I get 990x is equal to 456 take away 4, which is 452. So x is 452 over 990. Now it does say simplified. They both divide by 2. And that gives me 226 over 495. And frankly, I can't see an obvious factor there that's in common. So I'm going to leave it there. Now this next one is actually genuinely tricky. Let f to the n, or f of n, be 4 to the n plus 5 to the n plus 6 to the n. Prove by induction that fn is divisible by 15 for all positive odd integers n. This odd is really important. So we've got, of course, the n equals 1 case. So 4 to the 1 plus 5 to the 1 plus 6 to the 1 is actually equal to 15. So it's certainly true for n equals 1. Now, because it says odd ones, if we now look at the n equals k case, we can say that 4 to the k plus 5 to the k plus 6 to the k is equal to, say, 15m for some natural number m. But we don't go for k plus 1. We're going to go for k plus 2. Odd numbers. So we've shown it's true for n equals 1. The next one we need to show is 3. We can skip 2 altogether. So if we go up in 2s from 1, we get the odd numbers. So we get 4 to the k plus 2 plus 5 to the k plus 2 plus 6 to the k plus 2. Using our knowledge of indices, that's 4 squared times 4 to the k plus 5 squared times 5 to the k plus 6 squared times 6 to the k. So that's 16 times 4 to the k plus 25 times 5 to the k plus 36 times 6 to the k. Now, there's definitely a trick at this point, and if you do it differently, you're going to go all over the place. What we want to do is just take out a 4 to the k, a 5 to the k, and a 6 to the k. If we do that, we're left with 15 4 to the k's, 24 5 to the k's, and 35 6 to the k's. And of course, this stuff here is just 15m. Then I've got 15 times 4 to the k. Now 24 is 8 times 3. What I'm then going to do also is split this 5 to the k into 5 times 5 to the k take 1. And I'm going to do something similar with this one here. I'm going to say that that is 7 times 5 times 6 times 6 to the k take 1. So I've got 15m plus 15 times 4 to the k. And I can split out a 15 here. So I've got 15 times 8 times 5 to the k take 1. I can also carve out a 15 here with a 5 times a 3. That leaves me with 2 times 7. So I've got 15 times 14 times 6 to the k take 1. That means I've got a common factor of 15 that I can take out throughout, and I've got m plus 4 to the k plus 8 times 5 to the k take 1 plus 14 times 6 to the k minus 1. And there you go. It's divisible by 15. All I need is a concluding statement.